So here we are on part 7 of 10, how do meters work? All right, so we're going to talk about the current meter. We talked about the voltage meter in the last one. So hopefully if you watch that, this should be a little bit easier and intuitive because we have to do a little bit of math, right? So let's say that this shunt is that we're using right here. That I know that this picture says 0 ohms. That's not true. These all have a measurable resistance, right? And so one of them that we saw in the past was 0.001 ohms, right? Or 1 milliohm. And so that means that primarily, if you look at this, this is 1 milliohm and this is 500 ohms. The majority of the current is going to go through the shunt. Very, 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 very little current is going to go through this one if you do the current divider circuit. Okay, so if you the parallel resistance is much higher on the 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 arson voltmeter than it is through the shunt. So we were talking about a shunt before, and I know that this picture says that it's 0 ohms. That's not true. A shunt resistor is not 0 ohms, even though copper wire connecting it has a known resistance. So we'll just give it a value of 0.001 ohm or 1 milliohm, right? And that's just for us to have something on paper here. If you look, that 0.001 or 1 milliohm, however you want to look at it, is in parallel with this 500 ohms. So when you are putting this circuit in series with a load and a source, right, then primarily all the current goes through the shunt and not through your meter. Okay. So let's talk about this a little bit. This is a series connection, all right? And we're going to be passing current through it. So let's just remember that we're passing current through it, okay? What would happen if the resistance of the shunt were this first one right up here, okay? How much current will we be really able to measure? All right. Well, let's do the math on this. This is 5.0005 milliohms, right? Which is in parallel with 500 ohms. Well, a way to do this is you could go ahead and say this is 500 milliohm, or this is 500 ohms on the meter and 1 milliamp. If you multiply those two together, you get 0.5 volts. Okay, so we're expecting this shunt to drop 0.5 volts. So if we say 0.5 divided by the known resistance down here, right, which is 0.00, there we go, 500,005 equals practically 99.99. This is going to be 100 amps, okay? This is a 100 amp shunt. That's what this is, okay? And I understand that there's a small amount of error, but let's just bear with it, okay? So that's that one. This next one right here, well, it's the same math. You just change the numbers out, okay? So 0.5 divided by 0.05005, and this would be a 9.99 amp shunt, which is a 10 amp shunt. And we're going to do something here in a second. Actually, I'll just do it right now on this one. So you have, you still have 1 milliamp going in the other path. So plus 0.001 equals, and so we're getting closer, right? We're getting closer to the full 10. Let's go back and do that last one where it was 0.5 volts divided by 0.0050005, right? Or excuse me, that's 0.05. There we go. Equals, and then plus the 0.001 milliamp, right? Because the shunt's going to get that voltage drop, but this meter gets that voltage drop too, and it has a 1 milliamp going through it. So we get exactly 100, okay? So that's where the 100 comes from. We have to accommodate for all the current going through the shunt and through the meter itself, all right? Let's go ahead and do the next one, which is 0.5 volts divided by 5.05051, right? And so now we're actually measuring 10, well, let's add in our 0.001 milliamp, right? So we're actually measuring almost 100 milliamps. You can see if you round this up to the nearest, I'm just going to add 0.001, 100 milliamp. So this one is rated for 100 milliamps. And so let's go ahead and see what a circuit would look like if we were trying to install all those at the same time. So we're going to take that same principle from our voltage divider circuit where we were creating a voltage meter, and we're going to make a switchable selector that lets us pick different ohmic values to change that shunt out with, right? What we're actually doing is we're changing to a different shunt inside of the meter. So when you open up your old ammeters that had like a needle deflections like this one right here, what you'll see is that you actually have multiple shunts inside of them, okay? And these are the resistance ratings of each of those. And they were calibratable too, okay? So this is the current meter. And then in the next one, we're going to start talking about resistance.